Project 2.5 I2C Data Logger. This project explores wired communication protocols using two rails to communicate with multiple components at the same time. An I2C system uses two rails in addition to power and ground as a common bus for all components. Serial data and serial clock rails are split between the master and the chips and are controlled during communication by the master mostly, and are naturally pulled high to ensure a definition between high and low signals. Each peripheral has its own address, which the master sends along the data rail to initialize communication. A peripheral address is made up of 7 bits. The system begins communication with a peripheral by pulling the serial data line low, which is known as the start condition. During this condition, all peripherals listen to the master to hear if their address is being called. The peripheral with the called 7-bit address responds by pulling the data line low, indicating an accepted response. Then, the peripheral and controller communicate with each other by sending 8 bits of data across the serial data line while the clock pulse runs. This process continues until there is no more data to send and the end condition is reached. In this schematic, the serial data rail is marked in orange and the serial clock rail is marked in green. There are 7 construction phases in this project. The microcontroller, HID controls, real-time clock, TC74 temperature sensor, EEPROMs, an OLED display, and finally exterior construction. Then, there are countless software components and conditions. The first one is the beta condition, which is the default opening condition where no data is stored to EEPROM and the data is simply read from the TC74 temperature sensor and presented on the OLED display. After initiation in the beta condition, when the top of the hour is met after the system has been running for a while, the system transfers to the main condition. In this condition, all the data that is recorded is stored to EEPROM, averaged out for minutes and hours respectively, and then made available to be seen on the OLED display in various methods. This is the prototype of the beta condition, an image of the dot plot visual with 10 hours of data in the present, and an image of the standard visual as it's named, where the active timestamp and the data for however many hours ago is recorded. The way the visual and the data are presented are determined by the HID Human Interface Device controls attached to the ATmega328P microcontroller. These components are not attached in any way to the I2C bus. Unfortunately, the system was not able to work on its permanent surface, the PermaProto board, and its case. It does work on a breadboard, however. Thanks for listening.